We are back for July 4th's Leetcode. Happy 4th of July. We're doing 3307, find the kth character in the string game 2. So yesterday we did string game 1. We had to generate some kind of word and do a bunch of operations on that word. It looks like we're doing something relatively similar, but we have an actual operate. It looks like we have some sort of like actual operations list. So we'll get into that, and that's kind of the distinction. It is hard, so keep note of that. Alice and Bob are playing a game. Initially, Alice has the word A, like yesterday. You're given a and I'll read this in my head, and you can read it as well. Into operations. So the type of the ith operation. If it equals 1, if it equals 0, append a copy of the word itself. If it equals 1, generate a new string by changing each character in the word to its next character in the alphabet and append the original word. For example, performing C goes CD and performing ZB. So operation 1 is very much like yesterday, and this is different. And so the difference I see here is that this problem does not seem complex and or difficult at all. Um, the interesting thing here is that k is now 10 to the 14, and that means that we're gonna have to skip values. But I think we should code the basic solution first. But if we ran through each k value, would be here forever. So um, we gotta figure out how we can skip. But let's do the first. Let's figure out the solutions. It's actually gonna be pretty similar to yesterday. So I just want to see, how does operations. Let's say we run out of operations. Like, what happens? Um, the type of ith operation. So is it the case you can get the 5? I hopefully like this is always enough. Like 2 to the third is the index, the length of this should always be like the constraint here should be 2 to the len of operation should always be greater or equal to k. And that's because that for each value you double the length of the word. And so that this, let's say this is 2 to the third. If this is 2 to the third, it's 8. So the length of the output will be 8, and k is 5. So we can get um, the word of the index 4, or the 5th character. So let's get the result here. It's going to start with A, lowercase a. And similar to yesterday, we're going to go through for I in range of, or sorry, we should do a while loop here. While the len of res is less than k. This is very similar to yesterday. We went a little more in depth here. But while the len of the res, so while we haven't got to returning the kth value, and yesterday we were a little messed up on this. We didn't have k-1 here. It was a little bit of an issue. Not a big deal though. If operations of let me think about this for a second. If the len of res, sorry, let's do it like this. We really need an operations op. We need like an op I. So if the operations index, we need to keep track of that. Is there a say anything about operations? The input is generated such that word has at least k characters for every operation. Perfect. So I'm actually going to change this a little bit. We're going to do this a for loop. We're going to make this the len of the operations. And so now we can have some deterministic on this. Oh, now we actually don't need that. Okay, so now, um, so yeah, if operations of I equals 0, we are going to do something similar to yesterday, where we take for I in, or for char in res, we're essentially just going to move all the values one. So if we have A, we have B. If we have Z, if we have CD, we'll have DE, and then so I'll put new here, which is like that. I don't like using new because if you ever code in Java, you know what I mean. Oops, let's not make it bigger. And this is coming. This is gonna be a slow solution, and we're gonna get to the okay, new dot append. We'll do this in one here. It's gonna be the board char. Actually, it's not a pen. I get confused with like strings and arrays sometimes, but that's just because strings are actually arrays. Else, so that works, and then yeah, we want to at the end of wait, that's not the command I want to do. The end of this, we'll do res plus equals new. Okay, so that's kind of simple. That's actually very similar to what yesterday is, and that's operations of one. It's oh well, this is actually backwards. Okay, this is operations of one. That's operations 0. Right? Yeah. Okay, we had it backwards. Not a big deal. So I think this is actually the solution that's going to pass these test cases. Okay. We are not passing 0101. Let's do something similar to yesterday where we printed res. Let's see what we're getting here. Just make sure we are not. Oh, we didn't spell print right. Don't see anything at the moment. What could be going wrong? Interesting. We're getting A for everything. Oh, we're not adding one. Okay. Gotta add one here. That's the important part. Okay. So we had one, and that's kind of what yesterday's was. Right. So now we're getting accepted on that. Perfect. Okay. So as you know, the string is bounded by. So really, we're going to be doing k operations, or not exactly. Well, let's just submit. Let's see. I know this is not going to pass. Then that's the complexity of this problem. And look, the operations of length, you actually only run through the length 100. This is only getting run through 100 times. But look at K, it's massive. And um let's think about how this is bounded though. Sorry, if time limit exceeded. So I guess like this for loop is the problem, right? So for each one you're doubling the length, right? So this actually does go through 10 to the, I think it does go through 10 to the 14 or something like that. Because for each, yeah, it's got to go through 10 to the 14th because we do k minus 1 here. Yeah, so 10 to the 14th is massive. Just to like put into perspective, like it's like, jeez, that is a massive number. Okay, so literally we gotta be able to figure out how we can skip values, I guess is the best way to say. Um, Let me think here. I don't think this is like DP per se, but um, it's a hard, so expect to be some tribulations. So I think that this is fine, right? Like if 10 to the 14, can a string be that long? Is that okay? Like 10 billion? No, it's probably not right. String probably can't be that long. We got to figure out how we can skip, right? So here's the thing. I'm just thinking about it. If it's operation zero from any point, you can just use A. This needs to be fast. So how could we skip? Like it does feel deterministic in the sense that like for each value you could just double it. It's got to come from some algorithm. So what's interesting is that so let's kind of backtrack this, right? Because think about it, right? 10 comes from where? It comes from 2 to the third. It comes from 2 to the fourth, actually, because you need to go to 2 to the fourth. Um, minus 6. Or minus 5, right? Because so you'll have 16 values. Minus 5 will give us the 11th value. Or, I don't know, it might be off by 1 here. But how is this? Can we backtrack to where this is coming from? So it's 16, 8, 4, 2, and then 1. Let's start with yeah, let's start with K is 5 with the first one, just easier. Okay, so we have 0, 0, 0 or so we have A. Then it doubles to AA. Then it doubles to AA. Or sorry, it goes to AA. And then 2, 3, 4, 5. So what's interesting here was like thinking about it's a little bit like DP, but not really because like it's just a simple operation. But like the fifth value comes from here. Right, but it's coming. So the fifth value, right, think about it like this. The fifth value comes from the first value. Right? Think about it, right? So 5 minus the len of the previous equals the position of the last. So and then here we want to get back. We want to get back. Okay, so let's attempt this, right? Let's imagine we need the position of each. Okay, so let's. Okay, so this is what I'm thinking about. Creating a res, right? Or creating some array that keeps track of the positions of where we need to do. So, like, I'll give an example. So, for this case, right? So, this case is pretty simple, but it would be from the back. It would be 5, and this is starting at index space 1. It would be 5, 1, 1, 1. 5 isn't really that important. Actually, it's given to us. But we would do 5 minus 4 would be 1. Then it would be just minus the len of the last value. But it would be negative, so it would be maxed with, it would be set to 1. And essentially, we just need to, like, go through that. And now, that makes a lot of sense if we're just doing 0 operations. But now let's try this with some O and 1s operations. Let's see. So we have A, and then here will be AB. I'm just gonna copy whatever. No, wait. It would be AA, and what else does it becomes? AA, BB, and then AB, AA, BB, AA, BB, and then whatever the flip this is. Okay. So 10 is where? It would be here, 9, 8, 9, 10. Index. Remember, we're indexing by 1 here. So we would have B. So obviously be 10. We don't even need to, like, it would be 10. And then 10 minus 8. So it would be 2 here. Which is A. We need to keep track of its, if on duplication. Okay, the complexity here is like, if on duplication. Okay, yeah, so. Okay, I think I see it. If 2 to the n, 2 to, like, I is greater than k, don't do the operation. Sorry, not k. Is greater than, like, the cur k. You know what I'm saying? So, like for example here, right? So we're keeping track. So 2 is less than, this is the cur k. 2 is less than cur k minus 1. Oh, it's actually 2 to the I minus 1. Yeah. If that makes sense. So yeah, like, we don't want to duplicate, and we don't want to add 1 to any values that are in the first half sector. Essentially, we're looking at for the first half. If it's, yeah, okay. So if it's in the first half, we don't want to add an operation because we add the operations to the second half. And what we're really trying to perform here is we're trying to skip values. And what we're doing here is we're literally skipping. So I'm just gonna comment this code out, and I don't know if I'm being precise enough, but I hope this makes sense. This kind of formula where like we're doing, we're essentially like creating the array of the path at which it gets back to the original, and we're just gonna path find through the array. And honestly, um it should be O of one, O of 100. It should be O of 100. This should be a constant time. Let's see what we can do here. It should be O of operations, and yeah, I feel relatively confident about this. Okay, so um let's just comment res out too. Okay. We kind of figured it out in our head, but let's just put this over here too. All right. Let's just restart. We're gonna first um I don't even know if we need this, but we'll just do this. We'll set the length operations. We should have done this before, honestly, but um, operations. And then we're going to start while. K greater than 1. We want to get it back to 1. So we want to get K back to 1, right? Um, and this is kind of going to be the while loop of getting this array. Um, right, so we'll set the array. And essentially, we're just going to compile it. This, and we won't do it index based at 1. We'll index it at 0. So R of, or I guess I'm not sure. I think we're going to index by 1 actually, just for simplicity. Because I will R dot append K, and then how do we get the len of where we're at? It's 2 to the K, right? We need to find the next closest square that is next to K. That makes sense. So if we're at 2 to the, so the closest square is, right, 2 to the, so 2 to, this is going to be math here, 2 to the n equals K. Is that right? Or is greater than or equal to? Yeah, I think that's the equation here we want. So for this is going to get a little complex. We need to actually, we need to log K essentially to get the closest square. Okay. Closest, wait, we're gonna have to, we're gonna test this with a few values. I'm not 100% sure. So the closest square is gonna equal log K. Is that, can you even log? I'm not even sure. I don't think I've ever used log before. And we'll probably have to, pretty curious how this is gonna work. Oh, well, we're not gonna, we need to take out this while loop, but let's see what closest square gives us. Return close. Let's see here. Well, it's not gonna actually input, or it was okay. So 2. That's not right. Because we need to do log base 2. Okay. How do you do that? Python. We're doing log base 10 right now. math.log2. Okay. Wait. Yeah, it's literally just log2. Okay. Let's see what we get here, and let's see if this will affect 2.3. Yep, so we need at least 3. So we're going to take the ceiling of this. Okay. I love this solution. Okay, perfect. So now we have the closest square. Um, yeah, perfect. Okay. So we can move this. Oh gosh. Okay. Um, do we want to do while closest square is greater than 1? Yeah, that's so much better. Okay, so now we have the closest square. We wait, we append, and then we do close, closest, or maybe last square is better because it's not necessarily the closest. We can have a really close value. Like, you know what I'm saying? The closest greater square is really, actually really like that. I'm being really specific in my code here just because it's a little complex. Closest greater square minus equals 1. Then we're going to do k minus equals closest greatest square 2 times the closest greatest, or 2 to the n. Right, is that right? So what we're doing here is we're essentially cutting it by the square, so it would be 8. So if we have 10, it would be minus 4, which gives us... Wait, let's look at 10 for a second because that's a little weird. Minus 8. 10 minus 8. Yeah. It would be 2 to the... Yeah, it would be 2 to the 3, which would be 8, and then we get 2. Then we get... We'll do an or here. Or k is... Anyways, I think that I'm a little confused, or I just know what I don't want to go over here. Or k is... Let's do an and here. K is... No, we're not even using k. No, we're using it here. Okay. K is greater than 1 and... Right, because like if k equals 1... No, it's not exactly that. Because I think we want to take a max here. Or, yeah, max of 1. We essentially never want to get k below 1. And so now let's print r. And so we should get kind of what I said here, 5 1 1 1 and 10 2 1 1 1. Let's say here. Those are closed. Okay. Got to give it a second. I feel confident. I hope this is making sense, kind of how my thought process is going here. So we're getting 5 1, which is fine, I guess. Here we're getting 2, -2. Oh, wait. Is it the... Essentially, let's just put an if statement here. If 2, this is not perfect code, and I will have to clean this up later, but if 2 to the closest square, um, I do not love this at all. But the max is actually... Wait. I'm not exactly sure what's happening, but... Uh, yeah, it's not close. I know. It's going to yell at me. 2 to the third. Sorry, it's the other way. It's k minus. Okay. Okay. 5, 1. And here we get 2, 1, 1. Okay, so should we put k equals 1 up? That's right. I don't know if I'm making an assumption there that, like, where's my code screwed up? I'm not exactly sure, but maybe it's the case that you don't even need that. Anyways, okay. So we got this R, and I think that we have 5, 1, which is perfect, actually. And then we have 1, 2, 10. Okay, so let's now do the second loop, but this loop is going to be the calculation loop. So for I in range of we're actually just gonna do for val in R, and we're gonna actually have to reverse it because we did it from the back. So I'll reverse it, and now we're gonna have 1, 2, and 10. And then let's see here. So we have char, which is equal to a. All right, we're gonna keep one value. So we'll have 1, and then it's gonna ask how can we get... I see. Okay, you know what? Wait. It always goes back to 1, right? It always goes back to 1. Yeah, it will always go back to 1, right? No matter what the case is, it always goes back to 1 at some point. Yeah, okay. But it jumped from 1. Okay, I'm making a slight adjustment here, but I'm gonna have duplicate 1s in here. Because we need to know at which We honestly don't even need this, but we need to know where we are with multiple ones. We need multiple ones here. Um, okay, return. Wait, what? Oh, because the four. Now let's check what we're getting here. 511 and then 10211. Perfect. That's what I want to see. Okay. So now we are looping over n, which is the length of operations. So that's O of 100. That's snappity snap, and there's nothing that's important here. Okay. So per or okay. If I'm gonna need I here. Okay, enumerate. We're gonna enumerate because we need both. We're gonna need the index and the value. So if now here's what the plus. Okay, I'm not even gonna think about it. I'm gonna come back to it later, but here's where like the off by one thing might be an issue. But um, if 2 to the I m- 2 to the I, because that would be the previous, is greater than val. We just want to continue. Or actually, we're going to do this. And operations of I. I love that. Okay, that's perfect. Yeah. Well, char will be. So what we're doing here is we're saying, hey, um, if the value is in the if the value is is in the second half of the string, that means because we double every time, that means that it either if it's operation one, we added one from the previous iteration, so we need to do the char thing like where we do ord of char plus one or plus one here, ah plus one, and then char, right? Else we don't want to do anything. And then we just return char. I'm gonna just submit this. Let's see what we get here. Yeah, we're getting the right answer. Let's do a submit. I think that might be it. Okay. We're messing up some cases here. Let's see. Um, 6. Okay, let's just go through this example. Let's just see what we're missing here. So, A, 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 and then A. Just gonna put this here. Or, sorry, this is not gonna be, it's gonna be first operation is, that's the first operation. This is the second operation. This is gonna be the third operation. And then this is the fourth operation. Right? So I think the issue here is that we're doing too many. Yeah. This needs to be truncated. Essentially, it needs to go to me think about this for a second. We're close here, but what's happening is that we're starting here and we're doing 1 1. I'm pretty sure. So it goes, we get 6, right? Or we should be starting here. We need to chop some values off of closest greatest square is going to be 3 for this. For 6, it's going to be 3. So we only need, dude, yeah, I honestly think it's going to be closest greatest square instead. See what happens here. Yeah, that submits. Let's see what happens here. Okay, more. We got that run, right? But let's see what we got here. So now we got 0 1. Okay, you know what? I bet you this is gonna be a. Dude, I'm not even gonna. I'm just. I'm not. You know what? YOLO, right? YOLO, that's submit. I don't know. I'm just. Who knows what that. I don't know. I might have passed it actually. 390. How much did we have before that? Yeah, it is actually that. Okay, that's funny as hell. Okay, yeah, it's just whatever. It's a whatever. Okay, let's keep going though. All right, so or maybe this is back. I'm not sure. Okay. Let's see here. K is 3 and operations is 1 and 0. Okay, we expected A. Let's go through it again. So we double it to A, but we do AB here. Um, and then we do AB, AB, right? And we're looking for the third value, which is A. Makes 100% sense, right? Whoops. So I agree it's A, but we outputted B for whatever reason. Okay, so let's print R. Let's see what we're getting here. Just curious. 3-1. It's pretty good. So 3. So we start with 1, right? And if you know what, is that the issue? I'm gonna use this test case really quick. Am I actually messing this up? It might be. Yeah, yeah, okay. That is the problem. Okay. Um, but let's go through this example because this looks like it's an issue. So we expected C and we got B. So we double. Okay, let's just go through this again. I think we're just like on some edge cases here. So we got AA on the first iteration. I really don't like how this is A. You're actually gonna remove that. Second iteration we get AABB. Third iteration we get AABB BBCC, and the fourth iteration is AABB BBCC, and then BBCC CCDD. Okay. 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 We're going on 45 minutes here. Let's keep it going. Keep it going strong. We're so close. All right. So 11 is 8. And this is indexed by 1, by the way. 8. We get C here. Okay. I like C. 2 to the I. Wait a minute. Let me think about this for a second. So in this case, we get B, which is very interesting. Then we get 1. By the way, should we set this to 1? Right? Like, no, because operations of 0. Okay, never mind. Um, let's actually print char here. I think this is going to be a lot easier if we. I'm going to sneeze. A second here. Excuse me. Okay. Sorry. Let me print char here. It's just better to do that after the thing. Okay. A, B. So there's C. B. This should do. A. So if val is greater than. Right, I see it. Yeah. Wait. I'm missing a case here. I think if what we're doing here is it should just use the last value. But we always jump back to 1 here. So then it becomes AA. So what happens here is we do B. What we do is we jump. We start at A. Then we do A again. And then we jump to A again because we didn't notice that it's not here, so we're not doubling it. But we should take the last value that got spun. I think that needs to be a case added here where, like, if operations of close, but I'm not there yet. So what we were doing before was that saying like if it was in the second half, add one. If not, don't add one. But it should be 11, 3, 3. What if it's A again? It should be, sorry, if it's um op equals 0, op equals 1. Get it? Here op equals 1. So if the last value, I think like something like if the last operation, if it's in the first half, just go back one. Is that really what it is? Getting messy. It's getting messy. Okay. So what I'm doing here is I'm kind of backtracking in an interesting way where like it shouldn't be one. No, it should be K. Uh -1. Because we're skipping K, I think. Alright, so we need to print some things here. Okay. Closest greatest square -1. We'll print K. We just need to figure out where we're headed here. What's our head doing? Like, well, we're gonna get this, but let's delete all of the prints. Maybe we don't even have any other prints. Move these. Okay, let's just move these. Actually, we need this one. All right. We'll just do add extra print here. Okay, so let's look at what we're dealing with here. So when we come in, the closest greatest square is 3, and we're at 10. If it's in the first half of the C, oh my god, I'm so close here. So 11 is, we're at 10. 10, and we should get 3, because it's 8. So it's in the first half. So it's in the first half. We need K to be 8. It's saying is 8 greater than K. False. What? It's false. Okay. Very confused here. We're close, but now we're just gonna stop the recording for 1 second to think about it. Just been coding a little bit here and fixing some small bugs. My computer was like running out of storage. But what I did here was I took out the initial value here and I put the append in the beginning. I also noticed I was adding an array value here as well, so there was like two values getting added at once. And then I put these in if, elif, and else cases. I didn't really change anything else. I'm gonna submit here. I'm getting passing these test cases. We're passing 661 now. We are getting closer, but still some small bugs here. So let's look into this. We're getting B, and we should be getting C. So back to the drawing board. Let's look at this one because I mean we're close. I mean we're like enumerating every goddamn test case here, but we're gonna do it. Okay, so 12 is this is actually it. This is this one right here. 12 is C, and I agree with that. Well, it should be 12 4 4. Let's take it. Let's see what it's producing here. It should be 12 4 4 2 1. 12 4 1 1. It's 12 4 12 4. Honestly, I'm gonna take this here. I think this is the problem. Yeah, I think that's it. No. If 12 4 1 1, right? 12 sorry, 12 4 1 1. Wait. 12 wait. No, 12 4 here. That jumps. Should be greater than equal to, actually, I think. Yeah. Let's see. See the next cases if we're failing them. 900 out of 901. What the heck is that? Oh. We're not modulating. Dude, we didn't modulate either, by the way, on we're not modulating here. Wait, we're just adding one to the ord. Um, how do we loop back? I don't even know. Okay, we gotta do this in a few steps. So ASCII equals order of char, right? Then we're gonna need to minus 72, right? Is the ASCII value or is it 92? 92 is 0 is A. Then we need to um ask plus equals 1, but then we need to mod it by 26. And then we need to do ask plus 70 plus equals 70 92 again. And then we need to char that. Okay. That should be good. So now we are modding it, I think. We're getting this like what? What? Wait, what? Wait, are we doing it like is this because this is wait, we want to do plus one like this. I don't think it should ever be like that. Wait, we're modding it here. We got it. We got it. Okay, beautiful. All right, a lot of kind of all over the place here, a lot of testing, but I think I got the solution. I mean, it took over an hour, which is crazy, but we got the solution. So we'll just quickly kind of go over the logic here. So this is the logic for if k was a really small number, and I even mentioned yesterday, why is k so small? And that was because it was part one. But this would be the logic. It's pretty simple. If the operations equals 1, which means you do something where like you add 1 to all the ASCII values, so A goes to B goes to C, things like that, and operation equals 0, you just append itself. And it's pretty self-explanatory. We went through that. But here instead we created like a path through the operations, and I guess it's better to visualize it, but in this case we kind of made an array of where the values came from. So if we're looking for the fifth, we knew that the last value from the fifth came from the first, and then this value had to come from here, this value. So essentially we built this 51111, right? And then once we got that, we just started from A and found kind of what values are there. And this is the code. We will remove all these print statements now, but yeah, I think it's the cleanest solution. I think it's a very clean solution relatively. I think we could do a bit of improvements to it. Uh, around here specifically, I think this is a little like I think we could put a next square here equals, yeah, like this. I also think we don't even we actually should put this as we're not even using I when we should be. It should be I minus 1. We can just put next square here. Now we don't even need this. We could just do that. And we can remove this value. We're doing a lot in these steps. Let's just say, I might mess this thing up, but I'll put that there. Put that there. Then we could put I here. I know this is not as intuitive, I think. Let's see. We might have messed something up. That was a lot of movement. Yeah, okay. That was a lot of movement. But let's just go back to where we were. I'll go iteration by iteration. I'll do that off camera and make it a little cleaner. I was gonna make some changes, but I was like, I'm too tired to do that after. I'll leave a solution later, but for now, this is what I got. Thanks everyone for watching. I wonder what other people are doing. Beginner friendly. This guy's a nice, pretty good guy. He's got something a little bit, yeah, pretty similar. Actually, cleaner code than I have. Way cleaner code. Yeah. So this is probably what I would use as a benchmark. It looks relatively similar to what I'm doing. Yeah. So yeah, that was a first hard solved on YouTube, and it went strong. It was a little long, but it went strong. Thanks, everybody.